Hello guys, my name's Tan Ahmed. I'm a chemistry teacher and I'm going to attempt to record the GCSE course on chemistry from first lesson, which I'm hoping to do today onwards. I think the subject, when I teach it, starts with explaining to classes what chemistry is. And chemistry is a material science. It studies the science of the materials that are in our world, and it looks at how the materials will interact with each other when mixed together. So I want you to clearly understand it's a material science, and if you do, then it's going to be obvious where we should start. Well, clearly we're going to have to look at materials and start with what makes up materials. If we know what makes up materials, then we'll be in a position to explain their behaviour and their properties, and the subject will then get going from there onwards. So to get you started, what are materials made of? Well, that is a hard question. Structure and bonding topic, we'll get into it in more detail, but we've got to start somewhere, and the basic place to start is to say that everything in our world, all the materials, the air that we're breathing, the water that we drink, the clothes that we wear, or the materials that make us up as people, everything is made up of tiny. You cannot believe how tiny. So very, very tiny bits of stuff. Now, those very, very, very tiny bits of stuff, in science, we call them particles. So that's where we start. That's the starting point. The word particles is deliberately vague. It's a term that describes any tiny bits of stuff that makes up something. I'll get to that in a minute, but let's start. I've done a PowerPoint with a few slides, so let's just go through that. What is chemistry? Chemistry is the study of materials and the interaction they may have on each other when mixed together. What are particles made of? They're made of tiny bits of stuff. The air, the water, indeed the people are all made of tiny bits of stuff. The tiny bits of stuff that make us up, or anything, any material, make up any material up, are termed particles. Later, we will explain to you in more detail what these particles are. But at the moment, the vagueness is appropriate. In diagrams, the particles are represented as either balls in three-dimensional diagrams or as circles in a two-dimensional diagram. They are in reality various shapes and sizes, but we're not going to concern ourselves with the shapes. We're going to just draw them as circles for now. And then we get on to this arrangement. So how are these particles? How are they arranged? Well, they're arranged in different ways in different materials, obviously. However, if we categorize our materials, and we categorize them into solids, liquids and gases, then most materials can fit into one of those three categories, either a solid, a liquid or a gas. And the particles that make up solids have a very similar arrangement across all solids. And the particles that make up liquids are similar in all liquids. The particles that make up gases are a similar arrangement in all gases. The particles, however, in a solid arrangement are different to a liquid arrangement, which are different to a gas arrangement. So if I just pull up a diagram off the internet about how the particles are arranged, then I want you to learn how they're arranged using 3 descriptors. And I want you to learn the descriptors, and I want you to be able to draw the diagrams. Right, so here, solid, liquid, gas. The particles that make them up have been drawn as spheres, as balls. If we get to how the particles are arranged in a solid, 3 descriptors. Descriptor number 1, they are close together. You see, the particles there are close together. They're right next to each other. That's what I mean, close together. They are vibrating. They're vibrating in that place, but they're right next to each other. So descriptor 1, close together. Descriptor 2, there's a pattern. There's an orderly pattern. In solids, there's a 3-dimensional pattern. A 3-dimensional orderly pattern later we shall call lattice. But for now, I want you to know there's an orderly repeating 3-dimensional pattern, which I'm going to call the second descriptor, orderly pattern. And third descriptor is about how they move. How are those particles moving? Well, they're definitely not moving around each other. That would be wrong. They are moving in the sense they're vibrating. What we say is they're vibrating in their place. So I want you to say they're vibrating in their places. Those 3 descriptors I want you to learn. And then let's move on to particles of a liquid. And again, the particles of a liquid with those 3 descriptors, you must get your head around. So number 1, a lot of people get this first one wrong. The particles of liquid are close together. Watch. They are close together. Okay, maybe a teeny weeny bit further than when we had solid particles. But the liquid particles are indeed close together. Secondly, no pattern. Absolutely no pattern. You start drawing a pattern here, you'd be wrong. Don't draw a pattern, no pattern in the arrangement of liquid particles in a liquid. And thirdly, how they're moving. Well, now they are moving around each other, but they move around each other, and they move around each other slowly. So they move around each other slowly. 3 descriptors. Learn those for a liquid. And they are different to the 3 descriptors for a solid. Finally, how about a gas? This is a graduated flask, and imagine it full of air with these air particles. How are the air particles arranged? Well, 3 descriptors again. Descriptor number 1. See, they're not close together. Definitely not close together now. There are big gaps between the particles. Typically, if you've got a particle that size, the nearest neighbour will be like 1,000 sizes away from it. So I want you to just picture big gaps between all the particles. So they're pretty far apart, descriptor number 1. Descriptor number 2. What about the pattern? Well, there's no pattern. There's no pattern to the arrangement of gas particles in a gas. You take a photograph and they're all over the place. There's no pattern at any time you take a photograph. Third descriptor, how about their motion, their movement? Well, the particles now move around each other, and they're moving around each other rapidly and randomly. You'll see this phrase used in books later. Rapid random motion. At the moment, I want you to learn that they are moving around each other very quickly in all directions. So that's a three-dimensional diagram. Most of the time in an exam, you won't have to explain a three-dimensional diagram, but you will have to draw or perhaps explain a two-dimensional diagram. So I tried to find a two-dimensional diagram off the internet, and I found these kind of diagrams. Never found one that was labelled correctly, because these are labelled molecules. Well, you know, I told you things are made of particles, tiny, tiny bits of stuff. Well, later we're going to learn that those particles, there are three types of particles. The particles are sometimes, in a material, they're molecules. Sometimes they're atoms. And sometimes they're ions. So ions, atoms, molecules are all types of particle. But we want to just use the word particle today. They're not always molecules. So when this diagram says molecules, 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 I want to cross that out and put particles. Particles as the starting point for the subject is suitably vague. Molecules is getting more into exactly something that I will explain to you later exactly what a molecule is. So for now, can you see how the three descriptors, closeness, solid, close together, liquid, close together. That's the one that people get wrong when they're drawing diagrams. They draw big gaps. Can you see where my finger is? There may be a big gap there. I would say to you, if you have a gap big enough, put another circle in that big gap. There should be no gap big enough to put another circle in. The particles are close together. If you have big gaps, that is fundamentally incorrect. So I don't want big gaps, but I don't want pattern either. No pattern. No pattern, no big gaps. And with a gas, no pattern. Big gaps. Far apart. Close together. Close together. How about the movement? They vibrate. They are vibrating. The solid particles vibrate in their places. The liquid particles move around each other slowly. And the gas particles zip around each other, rapid, random motion. They move around each other quickly. So I want you to learn to draw the diagrams of particles in this way. And I want you to understand the diagrams that are three-dimensional. And if we understand the particle arrangements, that they're behaving like this, the particles, then we will link that with how those materials behave in our real world, what their properties are, whether they melt easily, whether they change shape, whether we put them down and they seem to disappear after a while because they evaporate away. All those things we can relate, and they are chemistry things, we'll relate later, but understanding how the particles are arranged is step one. Now, I want you to learn how the particles are arranged. I want you to understand how the particles are arranged. I want you to be able to draw how the particles are arranged. So I have a memory aid to try and help you in case you forget. Now, this might seem a bit of a daft memory aid, but I want you to perhaps use it if you forget how the particles are indeed arranged. And the memory aid I'm going to recount now is what we call an analogy. I'm going to talk about something that you're all familiar with and relate it to the arrangement of particles that I'm talking about. So, my analogy, what is it? Well, it's you. It's you when you're sat in a class, in a classroom situation. How are you sat? When you're all sat down in your places, you are behaving, in the analogy, you're behaving as a solid. Why? You are close together. You are in an orderly pattern. You are in a classroom, you're fidgeting, you're moving, but you're not moving around, you're vibrating. So vibrating in your places. Then what about you when you're doing practical? When you're doing practical, you are behaving like the particles of a liquid. Because, let's go through the descriptors again. You're still pretty close together. You're still in the classroom. You're still close together. You are not in a pattern because you're all zipping around the classroom and getting your apparatus, looking at the worksheet that you're doing, you're getting the chemicals, etc. So there's no pattern. And finally, you're moving around each other. You're moving around each other and you're moving around each other slowly. So that mimics the ideas I want you to think about of a liquid. And finally, what about solid? Sorry, not solid. What about gas? Well, the gas analogy comes at break time. At break time, when you leave the classroom and you're out going to the refectory, or you're going to your form room, or you're going to visit a friend within our school boundary, you are kind of like zipping around, and the three descriptors of a gas come from that, which is that you are big gaps between you. As a form, there would at break time be big gaps between you. That you're in no pattern. That you're moving around each other. You're moving around each other quickly. And so I hope that that daft analogy might help you to get your head around the arrangement of particles, and that will be a good thing for all. Okay, I'm going to end the video. Now next time I'm going to get into states of matter, solid, liquid and gas, and how we can change states of matter. You take care, and I'll catch you with you next time.